Good afternoon, grade 8s. Goeiemiddag almal, and welcome back to our geometry math tutorial in preparation for your paper 2 November 2023 exam. We are just over halfway through this tutorial and we are now moving to question 3, and we are looking at calculating the lengths of the unknown sides in the following triangles. So calculate the lengths of the unknown sides in each of the triangles below. Bereken die lengtes van die onbekende sye in elk van die drie hoeke hieronder. So we've got 3.1.1 and of course 3.1.2, and we can see that both of these triangles are right-angled triangles. Of course, what tells us that is the symbol here, this little square in the corner. That square indicating that this is a 90-degree angle. So hierdie vierkantige symbool, hierdie vierkant basis in daai hoek verwys na 90 grade, en dis hoe ons weet dat dit 'n reghoekige driehoek is. So albei van hier is 'n reghoekige driehoek. So they probably won't tell you in the exam or in a test to make use of Pythagoras in order to solve the following problem. So they won't specifically state the words Pythagoras. In other words, they won't guide you as to tell you that you should use Pythagoras to calculate the following sides, but you know that when you are faced with right-angled triangles, that you are able to make use of Pythagoras to calculate the lengths of unknown sides. So we will get straight into 3.1.1. So in 3.1.1, we have a right-angled triangle with sides 35, 12, and the unknown side x. Now, of course, we know that the unknown side in this particular triangle is the hypotenuse. How do we know this? So side x, the long side or longest side, is right opposite the biggest angle. So we can say that the hypotenuse over here, so the hypotenuse or die skynsy in Afrikaans, the hypotenuse is opposite the 90-degree angle. So die skynsy natuurlik in Afrikaans, die skynsy is reg oorkant die 90 grade hoek. Right, so that is how we know that we are needing to calculate the hypotenuse or the length of the hypotenuse side. And this is important because it influences how we approach the theorem of Pythagoras in terms of how we write out the equation. So we know that Pythagoras says the length of the hypotenuse, or actually not the length, but the square of the length of the hypotenuse. So the square of the hypotenuse, which in this case is x, is equal to the sum of the squares of the other two sides. I mistakenly made a degree symbol there. So 35 squared plus 12 squared. So the square of the hypotenuse, is equal to the sum of the squares of the other two sides. So net in Afrikaans weer eens, so hierdie magte of eksponente van 2 verwys na die vierkante. So die vierkant van die skynsy is gelyk aan die som van die vierkante van die ander twee sye. Dit is wat Pythagoras sê. That's what Pythagoras says. And once you make the statement, you will then write the reason for making the statement, and the reason is Pythagoras. So jy moet hierdie rede neerskryf sodra jy Pythagoras se stelling gebruik. So Pythagoras se stelling het ons gebruik om vir ons 'n vergelyking uit te sit sodat ons onbekende sy kan bereken, en ons moet dan die rede gee Pythagoras. So jy sal 'n punt kry vir die bewering, met ander woorde die vergelyking wat jy uitgeskryf het, en dan ook 'n punt vir die rede. So 'n punt vir hierdie en 'n punt vir jou rede. En dan natuurlik volgende is net wiskunde. So 35 tot die mag 2 is gelyk aan 1000 1000 225 plus natuurlik 144 en dit is gelyk aan 1369. So x to the mag 2 is gelyk aan 1369. Now please remember that 1369 is not the length of side x. That is the square of the length. In order to calculate the length, we need to take the square root of both sides. So I will take the square root of x squared and the square root of 1369. And that leaves us with x on the left-hand side. And the square root of 1369 gives us 37. So 37. So x is like aan 37.